Hello everyone, today I'm going to be talking about a 6th grade physical science standard. This standard is integrate qualitative, scientific, and technical information to support the claim that digitized signals are a more reliable way to encode and transmit information than analog signals. This standard is basically saying that students will understand that waves can be used for communication purposes. This would include devices such as light pulses, radio waves, Wi-Fi devices, and the most common are cell phones. As I said in the standard, there are two different types of waves. Those waves are analog and digital. As you can see here, the analog wave is a lot more busier than the digital wave. The analog wave has multiple values which vary in size. The digital wave only has two values. As you can see here, it is more consistent. The analog wave has more amplitude and frequency than the digital wave. The digital wave only has two series, which makes it more consistent and less busy. Digital waves are used especially for long distance wave travel, specifically talking on the phone. If you use an analog wave to talk on the phone, your result would end up being like the game that we used to play in school, where you would tell somebody something in their ear and you'd whisper it, and then they would tell somebody else, and they would tell somebody else, and you'd go all the way around the room, and by the time the sentence was said out loud, it was nowhere near the sentence that it started. This is basically what an analog wave would do if you tried to use it for talking on the phone, because since it has the more frequency, it can take in more sounds that are traveling, and by the end, what was said would be interfered with so many other noises that the result would not be the same. I'm going to show you an example of digital wave, and this is really fun to do with students as well. So here's my phone. As you can see, I'm turning on my phone volume. I'm going to put my phone wrapped in a piece of paper. Gotta make sure it is wrapped very good and is covered. Okay, I am going to call my phone. As you can hear, my phone rang perfectly fine through the piece of paper, which means that our wave was transmitted. Now I am going to use aluminum foil. My phone is wrapped tightly in the aluminum foil. Now I am going to call my phone again. As you can tell, it is ringing and it is calling. My phone is not ringing. Now when I check my phone, I will most likely still have the missed call. As you can see, it says now. Our electronic devices send and receive information through pulses and radio waves. Radio waves can go through most things, even walls, but there are some things they can't go through. Since you can hear that the phone rang when it was wrapped in a piece of paper, that means the radio wave went through. You'll notice that when the phone was wrapped in the aluminum foil, it didn't ring. This is because the radio waves cannot get through the cage that we created with the aluminum foil. This is why people sometimes lose reception in elevators and other places that have a lot of metal present. So that is a fun activity for students to see an example of waves traveling and, things that can interfere with waves, but also there are many different activities that can support the lesson of wavelengths and comparing them. I know that there is a activity with comparing songs that were recorded with analog and digital, and you can hear in the songs that are analog, there's a lot of different interferences, and in the digital it is more clear. So basically all this standard is saying is that you're comparing the two different wavelengths and you are seeing which one is best for communication, which is usually digital for most of your answers, and there are so many resources to teach this lesson. I hope this helps. Thank you.